Hello, welcome to a video on differentiation and coordinate geometry. This is meant for first year A-level, AS level, C1 exams. These are all past exam paper questions. This video is not really meant to teach you how to do this stuff before you've actually learnt it, so this is for revision purposes. Once you have learnt all these techniques, hopefully in class, you can practice these skills on these questions, and just showing you how you can attempt really complicated questions and improve your skills that way. This is the index page, so you can click on any one of these questions to take you to the question, or on each question there's an index button which will bring you back to this page. It should help you navigate the questions more carefully. These questions probably last over an hour, so try not to do them all in one go. Take your time, make sure you work through the question before you watch the answer. That will help you to understand it better than just sitting and watching. Well, good luck, and I hope this helps you to revise. Differentiation and coordinate geometry. I'm going to start with question 1, which is going to be fairly straightforward, probably the easiest sort of question you can get on this, and then we'll work through lots of questions till we get some more complicated ones. The basic skill we've got to know here is when we're differentiating something to do with x, so a function of x, so we're differentiating something, then when it's something x to the power of something, what we do is we take this number and we take it down and multiply by that. So we have a times b, so whatever number was there is multiplied by the number at the front. And then we take 1 off the power, so we end up with, looks like a 6, it should be a b. We end up with b minus 1. So that's the basic idea of differentiation. So we go from this to this when it's polynomial, so just powers of x. The other thing we should know straight away is any constant term we can just ignore when we differentiate, so we don't need to do the minus 3 because that becomes 0. So the 5x cubed, so let's break it down. So we take the power up here and we times by the 5, so we've got 3 times 5 x to the power of 3 minus 1. Okay, I'm going to do it in bits to start with, just so that we can see where everything's coming from. We've got the 6. The signs generally stay the same unless there's a negative power, which there isn't in this case. So we've got 4/3 times 6 x to the 4/3 minus 1, and in the last term plus 2x. Well, that has a power of 1, so 1 times 2 x to the power of 0. Oh, let's actually do it the way we've done everything. 1 minus 1. So I'm taking it really steady there, doing everything, showing you all the details. But you should be able to do this. 3 times 5. Now in A-level maths, I don't know if you realise this, but we often use a dot to represent multiplication. This is not 3.5. This is 3 times 5, which is 15. X 3 minus 1 is 2. 4/3 times 6. Well, 4 times 6 is 24. Divided by 3 is 8. So let's put 24 over 3. If you're not sure how to do multiplication with fractions very well, then just put it over 1 times the tops times the bottoms. 4/3 minus 1, well 1 is 3/3, so 4/3 minus 3/3 is 1/3. 1 times 2 is 2, and x to the power of 0 is just equal to 1. So we've got 15x squared minus 8x to the power of 1/3 plus 2 times 1, which is 2. So there's our answer. Each part of the answer is worth 1 mark, and there's a method mark for, I'm guessing, some showing of understanding of differentiation. If you get the answer though, you get all 4 marks. Now d2y by dx squared is just the second differential, so we differentiated once to get this function, this polynomial, and then we're just going to do it again. So d2y by dx squared. So going to be a little bit quicker this time. So this first term, we take the 2 times by the 15 to make 30. and when we reduce the power by 1, x to the power of 1 is just x. We take the third times by the 8, so we get 8 thirds. X to the power of, take 1 off a third, can be quite tricky, but if you take a third off you get 0, then 2 more thirds to get minus 2 thirds, and then again the constant term disappears. So it's just 30x minus 8 thirds x to the minus 2 thirds, and that's worth 2 marks, 1 for the answer and 1 for some showing of method. Not really showing any method there, just went straight to the answer. But when you get good at these, you should be able to go straight to this. The only thing that causes problems is the fractions, I think, and sometimes these fractional powers. Question 2. Again, another differentiation question. But to start with, we've got to be able to manipulate the powers of x so we get it into a form that is more easily differentiated. Now let's just look at this quotient we've got here. So we've got 2x squared. Now when you're dividing by the square root of x, that means you've got this part divided by the square root of x and this part divided by the square root of x. So we've got 2x squared divided by the square root of x minus x to the 3 over 2 divided by the square root of x. Okay, so when you've got a single term on the bottom, you need to divide that into both the top terms. Now the square root of x is the same as x to the half. That's the square root. The cube root would be x to the third, and the fourth root would be x to the fourth, and so on. So this term here, in fact, let's rewrite all of this. We've got 2x squared divided by x to the half, and we're going to take away x to the 3 upon 2 divided by x to the half. Now, if you go back to your powers rules, you should know when you're dividing powers, you subtract the indices. So the 2 doesn't make any difference, so we just put that on the front. So we've got 2 to the x squared minus divided by x to the half, which is x to the 2 minus a half, which is 1 1/2. Now we should really write that as 3 over 2. All fractions really should be written as top-heavy fractions because they're more easily manipulated that way. So the second one, minus x to the 3 upon 2 divided by x to the half is just x to the 1, because 3 over 2 minus 1 over 2 is 1. So what we've got here is 2x to the 3 upon 2 minus x, and q is 1. So that tells us that p is 3 over 2 and q equals 1. So now we've got to differentiate this long polynomial here. This part is what we've just done here, so we can replace this with this expression here. Differentiating this, we do the first term using the rules. The 4 we times by the 5 to make 20. We subtract 1 off the power, so that's x cubed. Any constant terms with no powers of x or no x's disappear. And this bit here is the same as 2x 3 upon 2 minus x. So the differential of this, we times by the 3 over 2, so it's going to be 3 over 2 times 2. I'll actually write that down. And then we're going to take 1 off the power, so 1 off 1 1/2 is just a half. And then x to the power of 1, we take 1 off that, makes 0, so that's just x to 0, which is the number 1. Just tidy that up, and we just got 1 1/2 times a half times 2 is 3. These 2's cancel. Think about that, the diagonals cancel to give us 3, and we end up with that expression there for 4 marks. Question 3. Okay, we're stepping up a little bit again. We're doing this slightly different format. We're using functions this time. Instead of y equals, we're doing f of x and f dashed of x. It's the same thing. F of x is just the same as y equals. It's just written a different way. And again, we've got this, similar to question 2, we've got this quotient that we've got to simplify into this polynomial. So we're trying to show that this is equal to that again. So again, if we think about each term, this top bit's squared, so we really need to do that first. So let's actually do that here. So the bracket squared means it's got two of the same brackets. When we multiply that out, we get 3 times 3, which is 9. 3 times minus 4, x root x, so 3 4s are 12, so it's minus 12 root x. And then we've got minus 4 root x times 3, which is minus 12 root x. And then we've got minus 4 root x times minus 4 root x, which is plus, careful with your signs, 4 4s are 16, root x times root x is just x. So we end up with that expression there where we've got minus 24 square root of x plus 16x. And we've got to divide that by the square root of x. So each of those terms, we've got 9 divided by root x, and we're going to change the root x to a half. Again, with more practice, this sort of thing, so we've got root x here, so that's x to the half divided by x to the half. With more practice, these sort of things become easier to run through without making a mistake. 9 divided by x to the half. 9 divided by x to the half, so that's, if you like, that's 9x to the 0 divided by x to the half. So that's the same as 0 take away a half, which is minus a half. So it's 9x to the minus a half. That's our first term. Really, we should know when we're just dividing by a power of something, it just becomes a minus power of that same thing. That's a quick way of doing it. These x's to the half cancel, so we just got 24, and we've got this plus 16x to the 1, x on its own, divided by x to the half, and we're just going to subtract those powers to give us x to the half. Okay, so that's our expression, 9x to the minus a half. It's nice that they've given you that one to give you a clue to make sure you're on the right track. I've got these the wrong way around, but it doesn't make a difference. A x to the half, so this is the a here. A equals 16. And then b equals the constant term, which is minus 24. Okay, so now we've got this expression. We can now differentiate. F dash that's the same as dy by dx of this thing where we've got where y equals 9x minus a half minus 24 plus 16x to the half. So we're differentiating this first term. The minus a half times by 9 is going to be minus 9 halves. And we've taken away 1 from that power to make 1.5, which is 3 over 2. The constant term disappears, and then we've got this end term. A half times 16 is 8. X, take 1 off the power, is minus a half. Okay, so that's okay. Now we've got to evaluate f dashed of 9. That just means we're going to replace x in this expression with the number 9. So f dashed of 9 is equal to minus 9 over 2, 9 to the minus 3 over 2, plus 8 lots of 9 to the minus a half. Now I believe this exam paper C1 is the only one you're not allowed to use a calculator on, so you've got to be familiar with your powers and how they work. So let's just run through this. Let's look at this 9. Let's actually do 9 to the half. Give us an idea. 9 to the half is the square root of 9, which is just 3. So 9 to the minus a half. The minus means 1 over 9 to the half, which is 3. 1 over 3. 9 to the minus 3 over 2. That's equal to 9 to the minus a half cubed. So minus a half we got is 1/3, and that's 1/3 cubed, which is going to be 1 over 27. So let's just go back to here. We've got minus 9 over 2 times by, let's not use times, let's use a dot, 9 to the minus 3 over 2, which we worked out here is 1 over 27, plus 8 times 9 to the minus a half, which is a third. I'll use a times sign again. Okay, so this, without multiplying this out and then dividing, this 9 cancels with this 27 because that goes into it 3 times. So this first bit is going to be minus 1 over 6, 1 times 1, 2 times 3, and then we've got 8 thirds. So we've got 8 thirds minus 1 6, we've got 8 thirds minus 1 over 6, which is 16 sixths minus 1 6, which is 15 sixths, and that cancels down, divided by 3 gives us 5 over 2, or 2.5, or 2.5 if you like your decimals. Okay, so quite a lot of marks there, starting to step up in a bit, 8 marks. Just the change of format with the function notation shouldn't really make any difference to how you do the question though. Question 4, again, make it a little bit trickier. Same sort of starting point, differentiating a polynomial, but then we're starting to use the coordinate geometry, show that a point P lies on C, because C is an equation of a line, or a curve actually, and then we've got to do a normal, which I'll talk about more in a minute. Okay, but let's just differentiate it. Let's just run through that. So take 1 off, take the power times by the fraction, so that's 3 lots of a half, which is 3.5. Take 1 off the power to give me x squared, that's one term. 3 over 2 times 9, do the 9 times the 3 is 27 over 2, x to the, take 1 off the power, 1.5 minus 1 is a half. And then we've got this bit, 8 over x is the same as 8x to the minus 1. When you've got fractions with x's and stuff, it's always easier to take it and put it into a numerical power like that, so that the minus comes down, so it's minus 1 times 8, which is minus 8. Let's actually remove that plus for a minus 8, and we take 1 off the power to make x to the minus 2, and the constant term disappears. You must remember that quite often people just write 30 on the end when they shouldn't. Okay, so that's the first one, worth 4 marks. I'm guessing you're going to get through 1 mark for each term and 1 method marks if you've done some sort of reducing the power by 1 and times them by it. That's your method mark. Show that the point P 4 minus 8 lies on C. So if this lies on this curve, that means that when we put x equals 4, y will be equal to minus 8. So what we do there is we ignore the y equals minus 8, and we just start with x equals 4. So we do y equals a half of 4 cubed minus 9 times 4 to the 3 over 2 plus 8 over 4 plus 30. And if that expression evaluates to minus 8, then we know it's on the line. If it doesn't, then it's not on the line. So 4 to the power of 3, 4 squared is 16, times by 4 is 64, and a half of 64 is 32. 9 to the 3 over 2, 4 to the 3 over 2, let's do that over here. 4 to the 3 over 2 is equal to 4 to the half cubed. So 4 to the half, the square root of 4 is 2, cubed is 8. So that bit there is 8, and times by 9 is 72. And then 8 divided by 4 is 2, plus 30. And 32 and 30 is 62, plus 2 is 64. Take away 72 equals minus 8. So that's therefore 4 minus 8 lies on C. Find an equation for the normal to C at the point P. Give your answer in the form ax plus by plus c equals 0. Okay, so the normal to a curve, if we've got some curve and we've got a point here, we'll call that C, then the normal is the line that's at right angles to the tangent. The tangent is at right angles to the curve, the normal is at right angles to the tangent. So what we need to do is work out the tangent to the curve at that point. Well, that's what dy by dx is. So dy by dx, when x equals 4, because that's the point we're using, gives us the tangent gradient, gives us the gradient of the curve at that point. And we just need to put the 4 into this expression, dy by dx. So we got 3 over 2 times 4 squared minus 27 over 2 times 4 to the half minus 8 lots of 4 to the minus 2. So 4 squared is 16. 16 times 3 over 2. Well, we divide by the 2 first to get 8. Times by the 3 gives us 24. 4 to the half is 2, because it's the square root of 4. And 27 over 2 times 2 is just 27, because the 2's cancel. 4 to the minus a half. 4 to the minus 2. 4 squared is 16, so to the minus 2, that means 1 over 16. And we've got 8 times 1 over 16, and that's just going to work out to be a half, because 8 times 1 over 16 is 8 over 16, which is a half. So we've got 24 take away 27 is minus 3, take away another half is minus 3.5. So that's the gradient of the tangent. We want the normal, so the gradient of the tangent is minus, and we're going to change that to a fraction because it's easy to manipulate. So the gradient of the normal is going to be the negative reciprocal of this. So we change the sign because the tangent's going this way. Just happens to be lucky it was actually negative. It's going this way. So the normal is going to be a positive gradient, so that changes to a plus. And the steepness of the gradient here changes by turning the fraction upside down to 2/7. So our general equation y equals mx, when m is the gradient, is 2/7 x plus a constant. Now we know it goes through 4 minus 8, so if we put those numbers in, minus 8 equals 2/7 times 4 plus the constant, and I'm going to use a time sign again. Let's stop doing that. Times 4 plus a constant. So that tells us that we've got 8 over 7, so we've got minus 8 equals 8 over 7 plus the constant. Take that over here, so we've got minus 8 and 8/7. Actually 8/7 is 1 and 1/7, so that's actually minus, that's far too small, let's just rip that out. Let's move that up a bit and redo. So let's go up to here. So we got minus 8 take away 8/7, which is 1 and 1/7 equals c. So c equals minus 9 and 1/7. Ideally we want to get rid of the 7s, so let's just change that to a top heavy, so that's 63, 64 over 7. So we've got y equals 2 over 7 x plus minus 64 over 7, and we need to in the form where these are constants, so integers, so we need to get rid of the 7s. We times through out by 7, so we get 7y equals 2x minus 64, and we want it all on one side, so let's take it all over to the right hand side, and we have squeeze it in here, 2x minus 7y minus 64 equals 0. Okay. You can have it with all the signs different, so that could be the same as minus 2x plus 7y plus 64 equals 0. It's the same thing, and rearranged it's the same. Okay, so a lot of marks for that last bit, 6 marks there. Lots of information required to solve this question, especially this important bit about the tangent and the normal. The more of those you do again, the better you'll get at them. Question 5. This question is worth 12 marks. Find d1 by dx given each term in its simplest form. So this thing here, let's just alter that to be 8x to the half. That's the square root of x plus 5. The 5 bit's going to disappear because we're differentiating. 2x to the 1. 1 times 2 is 2, so that, and the x cancels. Well, it becomes x to the 0, which is just 1. And then we've got a half times 8, which is a half of 8, which is 4x. And then this, we take 1 off the power to be minus a half. So dy by dx equals 2 minus 4x to the minus a half. Pretty straightforward 3 marks. I think when you're good at this sort of thing, it shouldn't be a problem. Okay, we're told that the point P on C has an x coordinate equal to a quarter. Find the equation of the tangent to C at the point P. Give your answer in the form y equals ax plus b. Okay, so a little bit like the last question, but this time we're not doing the normal just yet. We're just doing the tangent. In fact, I don't think we're doing the normal at all. We're just doing the tangent. So we've got a curve. Let's just, I don't know which way around the curve is going to be. Let me just work that out. Okay, I'll work this out. It's a negative gradient, so we've got some curve. It's coming down like this. At some point, the tangent, this point is where x equals a quarter. We're not sure what the y coordinate is. Find the equation of the tangent. So if we can find the gradient, which is this function here, when it's a quarter, dy by dx, that tells us the gradient of the tangent when x equals a quarter. So 2 minus 4 times a quarter to the minus a half. Let's have a look at the quarter to the minus a half over here. Quarter to the minus a half. The minus means 1 over. Now if it's a fraction, that just means turn it upside down. So that's the same as 4 over 1, which is just 4 to the half. And the half means the square root, which is 2. So let's actually give me a... Oh, and then you've got times that by 4. So we've got 2 times 2 minus 4 times this thing, which is 2. So we've got 2 minus 8, which is minus 6. So the gradient is minus 6. So y equals minus 6x plus a constant. Okay. Okay, what we need to know is what y is at this point. Now we've got the original equation up here, so we can use that. When x equals a quarter, y equals 2 times a quarter, using the times sign again. Two times a quarter minus 8 times the square root of a quarter plus 5. 2 times a quarter is a half. Square root of a quarter is also a half. Square root of 4 is 2. Square root of 1 is 1, so it's 1 over 2. And a half of 8 is 4, so that's the same as just 4 plus 5. Minus 4 plus 5 is 1, plus a half is 1.5, so or 3 over 2. So y is 3 over 2 when x equals a quarter. Y is 3 over 2. So we're putting that into here to find the constant term. 6 times 6 quarters is the same as 1.5. 6 over 4, which cancels down to 3 over 2, which is 1 over half. So we've got 3 over 2 equals minus 3 over 2 plus c. Add that over to that side, gives us 3, so that tells us that c equals 3. So y equals minus 6x plus 3. Okay, so that's 4 marks. And then we've got the tangent c at the point Q is parallel to the line with the equation blah blah blah. Find the coordinates of Q. So a point Q is parallel to this, so if we can find the gradient of this, then we can put it into this thing to find the x value. But let's just rearrange this. So this 2x minus 3y, so we've got 2x. Let's just write it again so I can see it. Let's take the x's and the numbers to the other side. So we've got minus 3y equals minus 2x minus 18. Divide by minus 3, we get 2 over 3x. And divided by minus 3 gives us 6. So our gradient is 2/3. So dy by dx equals 2/3. So that's equal to this thing here, 2 minus 4x to the minus a half. And hopefully we can solve this to find the value of x. So if we take away the 2, we get minus 1 1/3, so minus 4/3 equals minus 4x to the minus a half. Divide by the minus 4. Minus 4/3 divided by minus 4 is just 1/3 equals x to the minus a half. So if we square both sides, we'll get 1 over 9 equals x to the minus 1, and then we reciprocate it to get x equals 9 over 1, which is just 9. So x equals 9. So the coordinates of Q is, x coordinate is 9, the y coordinate, because it's still on the curve C, we know that y equals, so when x equals 9, y equals 2 times 9 minus 8, the square root of 9 plus 5. Just bringing that down from up here again, the equation of the curve. 2 9s are 18, square root of 9 is 3, 8 times 3 is 24, plus 5. 18 plus 5 is 23, take away 24 is minus 1. So our coordinates are 9 minus 1. 5 marks. Okay, so that's starting to get a little bit trickier. Knowing what to do on this final part is not easy, but if you think about what you've done before, it might help to figure out what to do next. Knowing that the tangent to C is parallel to this gives you this this value for the gradient of the tangent. Knowing that parallel lines have the same gradient is quite important. But yeah, the more you practice these, the better you'll get. Question 6. Now hopefully these are starting to look very similar each time we do these. We've got the same sort of function, we've got a polynomial, we've got this something over x thing which we need to manipulate. But the first thing we've got to do here is the point P on C has x coordinate equal to 2. Show that the equation of the tangent to C at the point P is this function here. So to find the gradient of the tangent where x equals 2, we need to differentiate this. So let's just change that to this. So we've got 9 minus 4x, and then we just change this bit here to be 8x to the minus 1. If that was over x squared, that'd be 8x to the minus 2, and so on. But as it's just the 1x here, that's just a 1. Then So x to the minus 1. So when x, so we want to divide by dx because we want the gradient at the tangent. So divide by dx, we're going to differentiate. The 9 disappears. We've got minus 4 times the 1 from here. X to the 0, which is minus 4. Then we've got minus 1 times minus 8, which is plus 8x. And we're going to take 1 off that to make minus 2. So that's the gradient. When x equals 2, divide by dx is going to be minus 4 plus 8 times 2 to the minus 2. 2 squared is 4, so 2 to the minus 2 is 1 over 4, which is a quarter. So that's the same as a quarter. Times by 8. 8 lots of a quarter is 2. So we've got minus 4 plus 2, which is minus 2. So our equation is y equals minus 2x plus c. Hopefully we can see that we've got this bit already. We've just got to get this number 1. It's always nice for them to give you the answer so you know what you're looking for. So we just need to, well, we need to know what the y coordinate is so that when we put a value of 2 in here and the y coordinate here, we can find the constant. So going back to the original equation up here, when x equals 2, y equals 9 minus 4 times 2 minus 8 over 2. 4 2s are 8, 9 minus 8 is 1, 8 over 2 is 4, 1 take away 4 is minus 3. So when x equals 2, y equals minus 3. So we put that into here, so when x equals 2, y equals minus 3. Now normally I'll be working down a page, I'm limited for space here, so when I'm going up here, I really should be going underneath. It should flow down the page. And likewise, when I'm going across the page here, this actually, if I was on a big piece of paper, I'd be writing it always underneath so that I'd be writing down the page. What do I get to? So putting that into here, y is minus 3 equals minus 2 times 2 plus the constant. Minus 2 times 2 is 4. Minus 4. Add that to the other side to make minus 3 plus 4 is 1. So 1 is equal to c. Okay, and then we're going to get a bit of a messy now. So y equals minus 2x plus 1, which implies y equals 1 minus 2x. Just changing the two terms around, keeping the signs in front of each term. So find an equation to the normal of the normal to c at the point P. So this is the tangent. The tangent has a gradient of minus 2. So the tan, let's write that so we can read it. The tangent gradient, the tan grad, is equal to minus 2. Therefore the norm grad is 1 over the negative version of this. So negative this is 2, so that's just 1 over 2. So we change the sign to make it 2 and then reciprocate it 1 over it to make it a half. Therefore y equals a half x plus c, and we know the coordinate. We've got the coordinate 2 minus 3 when x equals 2, y equals minus 3. Therefore minus 3 equals a half times, done it again, half times 2 plus plus c, that's what we're trying to find. So a half of 2 is 1, take it to this side, we get minus 4 equals c, which tells us that y equals a half x minus 4. Okay, so the tangent at P meets the x-axis at A, and the normal at P meets the x-axis at B. Find the area of the triangle APB. So when x equals 2, we have a point. Actually, it's -3, isn't it? Let's rip that out. Mess that up. Okay, when x equals 2, y is -3. That's the point P. And we know that the gradient, the tangent, has this equation where it's -2x plus 1, so that goes like that somehow. Where it's going through the number 1. Okay, and the other one is half x minus 4, so it's going to look something like this, where that is -4. Okay, so we know that this is -3. What we really need to know is what these 2 points are here. So just thinking about this has got to go up 3, and the gradient is 1/2, so for every 1 you go up 1/2, so that's 1, so 2 across, go up 1, so we're going to go up 3. We need to go across 6, so that's going to be 8. So this triangle here, if we go across, if we go up 3, then this has got to be 6 because the gradient's 1/2. Okay, so and this one, this gradient was -2, so for every 1 across this way we're going up 2, so that would be -1, -1, and then we go across 1/2 up 1, so that's going to be at 1/2. So this length here is 7.5 times by the height, which is 3, and then we just halve that, divide by 2. So 3 lots of 7 is 21, 3 halves are 1.5, so that's 22.5 divided by 2, it's going to be 11.25. Okay, a much more involved question, but the starting point, 6 marks there, is very standard, straightforward sort of thing we're doing. Find the equation of the normal again, put the gradient in to y equals mx plus c, finding the c, it's fairly straightforward. This bit here takes a bit of thinking. Obviously if you've got more space you can draw it out a bit more accurately than I have, and you should be able to figure that out using the equations of the tangent, wherever that's gone, the tangent equation here and the normal equation we worked out there. Should be able to work out that triangle. Okay, here we have question 7. Getting near the end of this video now. We have this figure of, which is the graph of this equation here. The curve crosses the x-axis at point A, so here, find the coordinates of A. Well, when it crosses the x-axis, the y-coordinate is 0, so we know y equals 0. That tells us that 0 equals 2 minus 1 over x. So if we add the 1 over x to the other side, we get 1 over x equals 2. Switch the 2 and the x around to give us 1 over 2 equals x. If you're not sure about that, you could times by the x to get 1 equals 2x, and then divide by 2, but it gives you the same result, x is 1/2. Show the equation of the normal to c can be written as that. So the normal is this line here. The normal is the line that's at right angles to the tangent. The tangent we get from the gradient function, which is the dy by dx. So, as in pretty much all the questions so far, we've got to work out dy by dx. The 2 disappears because it's a constant term. We've got this minus 1/2 x minus x to the minus 1. Sorry, not minus 1/2, minus 1 over x is minus 1 over x is x to the minus 1. So the minus comes down, minus 1 times minus 1, if you like, becomes plus 1, so it's just going to be x, and we take 1 off the power, which is x to the minus a half. You can write that as 1 over x squared if you like. But what we're doing here is we know that the x coordinate is a half, so the gradient when x equals a half is equal to 1 over a half squared. Half squared is a half times a half, which is a quarter. 1 divided by a quarter is 4. So this is the gradient of tangent equals 4. Therefore the gradient of the norm is minus 1 over 4. You change the sign, turn it upside down, reciprocate it. So that tells us that y equals minus a quarter x plus the constant. And we know that it's still the same coordinates, y equals 0 when x equals a half. So 0 equals minus a quarter times a half plus this constant. So a half times a quarter is an eighth, so it's minus an eighth, so c must be equal to 1/8 because we need to take the eighth over to the other side, the minus eighth to make plus eighth. So that gives us y equals minus a quarter x plus 1/8. Okay, now we want it in this form, so we need to multiply through by the 8. So we times everything by 8, y times 8 is 8y. Minus a quarter times 8 is minus 2x, and that's plus 1. Then we need to just put it all on the same side. So that gives us 8y plus 2x minus 1 equals 0. It does want it that way around, but it's the same thing, so I'm going to leave it like that. The norm to C at A meets C again at the point B, so that's over here. As shown in figure 2, find the coordinates of B. So we want to know where this crosses this. Okay, so we need this is a simultaneous equation that we need to solve there. So we want we know the y coordinate is going to be the same, so 2 minus 1 over x is going to be equal to this thing. We have where y equals that, so it's minus a quarter x plus 1/8. Okay, so we need to get rid of this x on the bottom. Probably the best way to do that is just to multiply through by the x. So we get 2x minus 1 equals minus a quarter x squared plus an eighth x. Multiply through by the 8 to get rid of the fractions. In fact, let's take it up there. 8 times that gives us 16x minus 8. 8 times this is minus 2x squared, and then we've got 8 times that is just x. Take it over one side, simplify it a little bit, so we take it over here, so we get 2x squared. Because it's going over this side, it becomes positive. Take this away, makes minus 15x minus 8 equals 0. So we have a quadratic. Clearly there's 2 points where this line crosses the curve. One is here at a half. So one of these answers is going to be a half, and the other one is going to be something else. So 2x and x, I'm guessing this is going to be minus 1, so that gives us a value of a half. Let's just check what that would have to be. That would have to be plus 8. So that's minus 8. 16x minus x is we got here minus x. I made a mistake. Yeah, that's plus 15x, isn't it? Be careful with that, so it's not quite right there. So minus x plus 16x is plus 15. Yeah, so that factorizes that. That gives us the x equals a half. when that's 0. When this is 0, x is minus 8. So that's the x coordinate, minus 8, and we want the coordinates. We need to know the y coordinate. I'm just going to put that into the straight line. This equation here, y is this. You could put it into the curve up here. In fact, I think the curve is probably easier. So 1 over minus 8. So that becomes 2 plus an eighth, which is 2 and 1/8. So we've got the coordinate minus 8, 2 and 1/8. Okay, last question, question 8. Quite a complicated question. It's 4 parts, lots of marks available. This would be one of the final questions on a C1 AS level paper. Starts off with sketching a graph, then we've got some differentiation, and then we've got to find the equation of a tangent, and then we've got to find the x-coordinate of another tangent that's parallel to this tangent. So it's using a lot of coordinate geometry and differentiation understanding. We start off by drawing a sketch of this graph. We have to say where C meets the axes. So let's just quickly draw some axes. Okay, now what we need to do here is to be aware of what type of shape graph this is. This is a cubic graph. When you're sketching, you don't need to plot points. You could work out some coordinates and plot them, but you just need to know what sort of shape this graph is. So if this is unfamiliar to you, then you could work out a set of coordinates, then plot them all, and you probably get a decent enough graph from that. But you should be able to, with the practice, be able to figure out things you need from the equation. So this is a cubic. Why is it cubic? Well, this is an x essentially plus 1, and this is an x plus 3 squared. So we've got an x times an x squared, which is an x cubed. And x cubed graphs look like this in general. If it was a negative x cubed graph, then it would be just the same thing but upside down like that. Okay, so then we can see these brackets tell us, because we've been factorised, what the solutions are. We've got a solution at minus 1 because that makes 0. So when the y-axis when you're on the x-axis, when y is 0. And the other solution is at minus 3, but this is a double solution. That means that one of these points, either this one or this one, just touches at minus 3. And now we know this one is going to be minus 1 and this one's minus 3, so this must be on the left hand side, minus 3, and this must be at minus 1. So it just touches, oh sorry, not that one, but there must be a point here at minus 1 where it crosses. Okay, so it's either that one or those two or these two. So we know it's at minus 3, so it's going to come up, touch the graph at minus 3, come down, and then go up through minus 1. So let's just make sure that's touching. So that's minus 3, that's minus 1. So that's the 2 points where it touches the x-axis. The other point, just to finish off, is this one. Where does it touch the y-axis? Well, that's just when x is 0. When x is 0, we have 1, and we have 3 squared, which is 9. 1 times 9 is 9, so that's touching at 9. So those are the 3 points we need to mark onto the graph. Okay, now on part B, we've got to differentiate this function. Now this is just a cubic, so what we need to do is multiply it out. I'm going to do that here. Let's just remove that bit of graph there, don't need that there. And multiply this out. So we've got x plus 1, x plus 3 times x plus 3, because that's squared. This bit here should be fairly easy to multiply out. So we'll do that first. X plus 3, we get x squared, we get 3 times 3, which is 9, and the bit in the middle, which is 3 times x and x times 3. Add them together, you're going to get 6x. Now with a bit of practice you should be able to do those really quickly, especially when they're both pluses. And as this is all pluses, we should be able to just go through and do the powers one at a time. So x times x squared is x cubed, X times 6x is 6x squared, plus 1 times x squared is 1x squared, so 6x squared and 1x squared is 7x squared. X times 9 is 9x, plus 1 lot of 6x is 15x, because you've got the 9x and the 6x. 9x, 6x makes 15x, and then we're just left with the 1 times the 9 to finish off. So that's what y equals. So dy by dx is just the differential of that. Differentiate the x cubed, we get 3x squared. Differentiate the 7x squared, we get 2 lots of 7x to the 1. Now I'm putting that in because it says show that. I mean, from here you should just be able to write down the answer, but it's a good idea just to show you know what you're doing. 15x is just going to go to 15, the 9 is just going to be 0. So that just gives us a little showing that we know what we're doing. But really we could have just gone to this straight away. You've got to be careful though, because they have given you the answer. But that's mainly just to check, make sure you multiply this out properly. If you multiply this out, get this, and you don't get that when you differentiate, you've made a mistake, so you need to go back and check it. Or, when you carry on with the question, just use this value. Down part C, we've got to do an equation of a tangent. So we've got our graph here. So at -5, we're down here somewhere. We've got a tangent, which is a line just touching the graph, and we've got to find its equation. So we need to find the gradient to give us the m value, and then we'll need to find the y-intercept of the line by using a value of x and y. We've got the x value, we need to work out a y value. So let's just find the gradient first. So we've got the gradient function here, and we know x is -5. So when x is -5, dy by dx, the gradient of the curve is going to be 3 times -5 squared, that's the first bit, plus 14 times -5, that's the second bit, plus 15. And that gives us 3 lots of -5 squared is 25, minus cancels, so we've got 3 lots out, which is 75. 14 lots of -5 is -70, and we're going to add 15. When we do all that, we get 20. So the gradient is 20, so we know y equals 20x plus something. Okay, so if we know what y is and what x is, we can work out something. So I'm going to use the original equation when x equals -5, y equals -5 plus 1, -5 plus 3 all squared. So that's -4 times by -2 squared. -2 squared is 4. 4 times -4 is -16. So that's our y value. So that tells us that -16 equals 20 times -5 plus the constant. So -16 equals -100 plus a constant. So the constant equals -16 plus 100, which is 84. So that tells us that y equals 20x plus 84, and that's the equation of the tangent. Now, next question, we've got another point B lies also on C on this curve, and the tangents to C at A and B are parallel. So what we're looking for is another line that is parallel to this one. It's probably going to be around about here somewhere. So they're parallel and they have the same gradient if they're parallel. That's what parallel tells us. So if they've got the same gradient, then the dy by dx is equal to 20, and we know that the function for that is 3x squared plus 14x plus 15. So we've got to make that equal to that. Now we know one of the answers is -5, we just need to work out the other one. So We make it all equal to 0, so take the 20 over to the other side, so we've got 3x squared plus 14x, take away the 20 because it's minus 5 equals 0, and then we need to factorise that, and one of them is going to be 3x, one of them is going to be x. Now we know one of the answers is minus 5, so that tells us that the x that's on its own is plus 5, and the only way to make minus 5 when we multiply by plus 5 is minus 1, so that pretty much gives us the factorisation. Let's just check it works. 3x times xx squared minus 1 times 5 is minus 5, minus x plus 15 gives us 14, so that works perfectly. And we want this one, so 3x minus 1 equals 0, so that tells us 3x equals 1, which also tells us that x equals 1/3. And there we have it, that's the x coordinate of B, the point, which is also parallel, point of the tangent that touches, that's parallel to the other one. Okay, a very long involved question using all the skills of differentiation and coordinate geometry, and if you can master this you can do any question like this on the exam.